Number 5. Here is a hand drawing of the figure. So the graph of the function f, this is f right here, consisting of 3 line segments is given to the right. So they say g of x is the integral from 1 to x of f of t dt. What that means is if g is the integral of f, then f is the derivative of g. So remember, g prime of x is f of x. So now the other thing on it, since g is the integral from 1 to x of f, we consider g to have a 0 value at 1. So g of 0 is 1. That's just a little trick to remember. So now, part A. They say compute g of 4 and g of negative 2. G of 4 and g of negative 2. So if g is 0 at 4, or g is 0 at 1, then we need to add up positive area over here from 1 to 3, because I believe it goes through there. Yeah, I should have done that better. It goes through 0 at 3, and then we have negative area from 3 to 4. So remember, g of 1 is 0 at 1, 2, 3, and that's 4. So then we add up positive area, and then negative area, and then g of 4 is going to be, g of 4 is 2.5. Now g of 6, sorry, not g of 6, g of negative 2. If we go the other way, if we go left, notice that's this area here. I'm going to do this in blue. That's this area here. But since we're going left, we essentially add in negative area. You can think of it this way. So here's whatever it is at 1, going from negative 2 to 1, we add in a bunch of positive area, which means it's going up to the right. And then it keeps going up until we hit 3. 1, 2, 3. Then it stops, and then it comes back down a little bit. So if we had to go up to the right to get to 0, we have to go down to the left. Or you can think of it as, if we go to the right, we add on positive negative area in the normal way. If we go left, it goes the opposite. So then g of negative 2 is negative 6. B, find the instantaneous rate of change of g at x equals 1. Well, we want g prime of 1. Well, we know that g prime, so since g is the integral of f, g prime is f. Make sure you've got that in your mind. So we just read it off the graph. So g prime of 1 is 4. Because remember, g prime of 1 is the same as f of 1, which is 4. C, find the absolute minimum and value of g on the closed interval. So now notice here again. So at 1 we now have a value 0. We add on a bunch of positive area and a little bit of negative area. So it goes up a bit and then down less. So you can see this negative area is nowhere near this positive area. So it's not going to come back down to here. Now, as we go left, we have positive area, so we're going down because we're going to the left. So we know that the minimum has to be here at negative 2. And for part A, we found that f of negative 2 is negative 6, and that is our minimum. D, the second derivative is not defined at 1 and 2 because notice this is the first derivative. F is the derivative of g, so g's first derivative is this thing. And then the second derivative, which is the slope of the first derivative, we have a kink there and a kink there. So it's not defined at 1 or 2. But, so what we do know is the second derivative will have a positive value from -2 to 1 and a negative value from 1 to 4. Let's see, how many of these values are x-coordinates of points of inflection? So notice we go from a positive slope of the first derivative, which means a positive first derivative, to a negative slope of, positive slope of first derivative, which means positive second derivative, to a negative slope of first derivative, which means negative second derivative. So at x equals 1, we go from plus g double prime to a negative g double prime. So that is an inflection point. Now notice the concavity changes here, but it's negative and negative, so it is not an inflection point. Now, let's see. Oh, and that was D. So that is number 5.